Now, the most modern method of soil stabilization is the geotextile stabilization. So, geotextile is what it has been in use since early 1970s. They were used to wrap compacted soil in layers to produce a stable composite structure. And geotextile reinforced soil somewhat resembles the popular sandbag walls which have been used for some decades. What are the type of geotextiles? Geotextiles are basically made up of polymers such as polyester or propylene. They are divided into three categories in which they are prepared. First one is the woven fabric. This is a woven fabric. This is a type of geotextile we use soil stabilization. The next one is non-woven fabric. This is a type of geotextile which is available in form of sheets. Next one is knitted fabric. This is a knitted fabric, a knitted geotextile which we use. Next one, as you can see, what are the function of geotextile? The function of geotextile is filtration. It prevents, it is useful for drainage purpose, it is used for separation, it is used for reinforcement and sealing. These all functions can be well explained or well understood through these diagrams. The first one is a comparison of two soils. One is without geotextile and one is with geotextile. As the load of a wheel comes, a soil sample without geotextile can be displaced and can be not that much stable in comparison to a soil stabilized with a geotextile. The geotextile, the type of geotextile we discussed above, woven, non-woven or your knitted fabric, can be used in sheets in this form and can stabilize the soil and can hold the layer of the pavement. This is the effect of geotextile, as you can say. This is another diagram which is explaining about this is another method which is explaining about the effect of geotextile. It can be used for the filtration purpose, drainage purpose. In the particular type of in all type of pavements and in all type of roads, the basically problem is the water stacking problem, which is solved by the geotextile, by the presence of geotextile. Next one is the separation. You can use as in this figure, one portion is without geotextile and other portion is with geotextile. So your road surface is divided, your road pavement is divided into different layers. In right hand figure, as we can see, with the presence of geotextile, the crushed aggregate layer and the fine aggregate layer is being separated in a nice way, and without geotextile, as the impact of the wheel comes, this separation is not seen. Next one is reinforcing one. This is the total hole diagram which is explaining how the geotextile is helpful for the drainage purpose, for the separation purpose and for the reinforcement purpose. So these were the type of geotextile and the function of geotextile. Next, for the use of geotextile, once when it was decided or when it was discovered that the geotextile can be helpful for the soil stabilization, then two basic tests were conducted along with the basic stability bearing test and all. First one was the CBR test. CBR test is defined as California bearing ratio, which is basically a test to evaluate the strength of the subgrade, the soil subgrade, which is used as the basic lowermost layer of a soil pavement. So the CBR is an empirical test. In this particular test, we take readings on two scales. One is, for we know about the load carrying capacity of the standard stone sample, and we have to evaluate whether your soil is how much closer to the strength of the stone sample. As we know, we in CBR test we have discussed earlier also. In CBR test we take readings at 2.5 mm penetration. So the readings are taken at 2.5 mm penetration and 5 mm penetration. We have a CBR sample, CBR testing machine. So it was observed that higher would be the CBR rating, more difficult would be the penetration of the soil. It is clearly seen that due to the placement of non-woven geotextile, the CBR value increases. That means more is the CBR value, lower is the penetration rate, and more difficult is the penetration in the particular type of soil. This is an experimental analysis of two types of sample, one sample A and another sample B, with two type of cases, one with a geotextile and one without a geotextile. We take readings at 2.5 mm penetration and 5 mm penetration. So you can, as you can see with these values, that after the placing of geotextile, the CBR value increases. CBR value increases, that means strength increases, lower amount of penetration is seen. The next one is the compaction test. As you can see, next one is your compaction test. As you can see, there are two types of sample. Sample A is without geotextile and sample B is with geotextile. Basically you have to you are stabilizing the soil with the help of geotextile, and in sample A we can observe that at large amount of water content you can observe higher maximum density, but with sample B you can observe a higher amount of maximum density at lower water content, that means lower OMC. So the lower OMC corresponds to higher. That means this is the same type of difference which we observe in standard Proctor test and modified Proctor test. That means a soil sample with a geotextile, non-woven geotextile, can offer more amount of a more ideal value of compaction and more higher value of dry density. So this was a brief discussion about soil stabilization. All the methods have been covered, all the methods have been discussed. Thank you.